So with order of operations, we follow this phrase called Pemdas. So that's Pemdas right here. What it does is it gives us an order to follow when we're simplifying expressions. So the P represents parentheses, which are grouping symbols. You may see this as just kind of standard parentheses. Sometimes we use square parentheses. There's even kind of these squiggle brackets that help us group pieces together. And basically what we'll do is we'll simplify what's inside first, and then we can start working on the outside pieces. The next piece that we work on, the E, is exponents, so simplifying any exponents down. Then where it says M and then D, really there's no order to this. These kind of go together. So multiplication, division, which are very similar operations. I could almost say they're the same operations, just kind of different organization to them. What we'll do is if we see multiplication and division together, what we do is we simplify reading from left to right. So I'll give an example with that down below. Same thing is true of the A and S at the end, so addition and subtraction. We perform those at the same time as well, and just reading from left to right. So that's PEMDAS. Let's take a look at how this works. So with this first example here, what I can do is see that we have parentheses. So with the parentheses, I want to simplify what's inside first. So that means everything else just stays the same. So I still have this 12 minus, but I want to take care of that 2 plus 3, which is equal to 5. Then there are no more parentheses, no exponents, no multiplication division. All I'm left with is subtraction. So I just take care of 12 minus 5, which is equal to 7. Now with these, where you're just calculating numbers, part of your work will be to show your steps here. But if you want to double check your answer, you can use a calculator to help out. So what I could do is use a calculator and I just want to type it in exactly how I saw it. So 12 minus, and then parentheses 2 plus 3, close those parentheses, and there I can see I get my 7. So this can be a tool to double check your answer. All right, this one here is all multiplication and division, so no parentheses, no exponents. So where it says M and D, like I was saying, there isn't really an order to that. You want to think of M and D at the same time, and what we want to do is just read from left to right. Meaning, if I read 12 divided by 3, that's what I'm going to calculate first. So I'm going to take care of this 12 divided by 3 first. So 12 divided by 3 is 4, and then we still have this times 2. Now I can take care of the multiplication, which is 8. So a common mistake that happens here, if I do this to the side, is to think that multiplication goes first. So taking care of that 3 times 2 would make this 12 divided by 3 times 2 is 6, and 12 divided by 6 is 2. Notice that we get a completely different answer, and this is incorrect. This is a wrong answer here because this isn't following the order of operations. So we think of multiplication, division as the same, and then just start going left to right with it. Where this would have been correct is if it had looked like 12 divided by, and then in parentheses, 3 times 2, then this would be correct work because we would do the parentheses first. So 3 times 2 is 6, and then we would do the division. But without the parentheses, the 8 would be our correct answer. All right, here we have a few sets of parentheses. And something that you can do that helps students is where you see addition and subtraction outside of parentheses. This separates things called terms. So I could do is see that I have this first term, 5 times 1, and then I have this second term, 3 minus 2. So what we want to do is, since addition and subtraction comes very last in our order of operations, we want to kind of keep that as is, keep the plus symbol there, but simplify each term before we add them together. So over on this left-hand side, this 5 with parentheses of 1, this is multiplication. If you just have parentheses with a number, It's kind of this hidden form of multiplication. So that's just a 5 times 1. So for that term, 5 times 1 is 5. And then plus 3 minus 2 is equal to 1. So now that we simplified those terms, 5 plus 1 is 6. Now, we could have done this kind of more strictly following PEMDAS, and what that would have looked like is, if looking at this, first I thought about parentheses. Well, this first set of parentheses with the 1 is completely simplified, so there wouldn't be anything to do there, but I would simplify this 3 minus 2. So what that would look like is I'd still have the 5 times 1 plus 3 minus 2, which is 1. And then order of operations would tell me to take care of the multiplication, so the 5 times 1, and then I still have the plus 1 and the 6. So some extra steps there, but this more strictly follows order of operations with PEMDAS. But you can kind of work through PEMDAS simultaneously in this form if you think about the separated terms and simplifying each of the terms. All right, this one here, we have parentheses with a 3 plus 4, so I need to simplify the parentheses before I do anything else. So 3 plus 4 is 7. 7 squared is 49, and just as a little review of what exponents do, this is telling us to take 7 times 7. So multiplying that number to itself, and with that exponent of 2, it's telling us to multiply to itself 2 times to get that 49. All right, this one here, we have 2 sets of parentheses. So typically what we can do if we want to do one at a time, you can read left to right. That's kind of the best way to go about it. So we could just take care of that 39 minus 7 first, which is 32. And then we still have that 2 plus 3. And then that 32 is all simplified, so that's going to stay as is, but the 2 plus 3 we need to simplify, which is 5. And then we just have these 2 sets of parentheses, and when they're next to each other like this, that's our multiplication. So we would take 32 times 5, and we could use a calculator to help us out here, and that will be 160. Now, you could have simplified these at the same time since they're separated like that. So if you skipped this step, that's completely fine there. But if you like to write out each of the steps, that's what it could look like. All right, then our last one here. When you have a fraction separated like this, you're really working on the numerator and denominator separately. So up here is our numerator, down here is our denominator. And what we want to do is completely simplify the numerator and completely simplify the denominator before we divide anything. It's kind of like we have these hidden parentheses here. It's like this is in a set of parentheses and this is in a set of parentheses. So we need to simplify everything in there and everything in there. Now, what can be helpful for students here, if you want to, you can break it up as kind of side work. Like say we just wanted to focus on the numerator. What that would mean is we would just be taking that 7 plus 2 times 4. And what we're trying to do is simplify this so that we just get a number out up there. So what we can do is just focus on this. And using our order of operations, we have parentheses. So that's 7 plus 2, which is 9. And then times 4, which is 36. So my numerator is going to simplify to a value of 36. And then we're going to be dividing by whatever we get down there. So now what I can do is separately work on the denominator, which is that 18 divided by 3 plus 3 in parentheses. So first thing we're going to do is simplify the parentheses. So we have 18 divided by 6, which is equal to 3. So now what I can do is return back to up here, and where I see the denominator there, I'm going to simplify that to 3. So 36 divided by 3, which is equal to 12 for our final answer up there. So that's one way you can do it if you want to work on it all at once. In fact, I can show you how that would look. Really, it would look just the same as what I showed down here, but it would just be all together. So like what I would do is, looking at the numerator, I would take care of that 7 plus 2. In the denominator, I would take care of that 3 plus 3. So my next step would look like having 9 times 4 over 18 divided by 6. And then I would just simplify each of those. So the 9 times 4 is 36 over 18 divided by 6, which is 3. And then that would lead us to 12. So if you wanted to show your work all at once within the fraction, that's how it would look like. But if it's helpful to separate it up, absolutely go about it that way. You're still showing the same amount of work. It just can be a little easier for our brains to look at it separately rather than all at once.